All right, welcome back everybody to our chapter on logic and reasoning. Okay, in section 2.3 today, we're going to look at something called biconditionals and definitions. Okay, biconditionals are going to build right off of the work we did with conditional statements in the last section. And the reason we're doing this is biconditionals go right along with good definitions. And as we know, it's important to be able to write a good definition to be able to decide whether or not a definition is good. Okay, so that's what we're doing here today. Objective to write biconditionals and recognize good definitions. All right, so what is a biconditional? Let's say it's a single true statement that combines a true conditional and its true converse. Okay, so we talked about conditional statements and converses in our last lesson. Remember, to get a converse from conditional, we flip-flop the hypothesis and conclusion of that conditional. Okay, so kind of symbolically, we could say a biconditional combines if P then Q, and its converse if Q then P as this P double arrow Q, which we can read as P if and only if Q. Okay, so drop the if then, put the if and only if between the two, and again, what that's going to do is combine the conditional and the converse in one step. All right, so let's take a look at some examples of biconditional statements. Problem 1, part A says, what's the converse of the following true conditional? If the converse is also true, rewrite the statement as a biconditional. Okay, so I'm given a conditional statement. If the sum of the measure of two angles is 180, then the two angles are supplementary. Okay, conditional if-then statement. Now, in our last lesson, we learned how to make the converse from this statement by flip-flopping the hypothesis and conclusion, where the hypothesis would be the sum of the measures of two angles is 180, and the conclusion would be the two angles are supplementary. Okay, so if we flip-flop those around for the converse, and I'm just going to type this, we'd say if, the second part first, two angles are supplementary, then we'll do the first part second, the sum of their measure is 180. Okay, so I'm going to say that's the converse of the conditional I'm given. Now, if the converse is true, we can write a biconditional. I'm going to say in this case it is. If two angles are supplementary, then the sum of their measure is 180. That's basically the definition. So what I can do then is I'm going to write the biconditional which would be just basically an if and only if, where the then is. We could say the sum of the measures of two angles is 180, comma, if and only if the two angles are supplementary. Okay, so the sum of the measure of two angles is 180, if and only if the two angles are supplementary. Okay, that's the idea behind the biconditional. And the whole point of that is it combines the original conditional and the converse into a single statement. When I say the biconditional, I get both statements happening at the same time. I get both conditionals. Okay, bi is in two conditionals at once. Okay, that's part A. Why don't you pause the video, give part B a shot, make sure you can write that biconditional. Okay, and then hit play to actually check your answer. So in part B, same idea. We want to take a true conditional, figure out if its converse is also true, and then if so, we want to make a biconditional out of the original conditional. Okay, so to do that, we'll take our conditional. If two angles have equal measure, then the angles are congruent. And we'll write its converse first. Okay, flipping the order, we just say if two angles are congruent, then the angles have the same measure. So we run out of room here. So that's my converse. Now I'm going to say that converse is also true, just like with the conditional. Okay, because if angles are congruent, they do have the same measure. That's how we define congruent angles. So what I can do then is I can write the biconditional, which will take either one of these two statements and just put the if and only if in it. And I say either one because since they work in both directions, it doesn't matter what order we write the biconditional. So I could say that two angles have equal measure, if and only if the angles are congruent, as I run out of room here. Okay, so that'd be one way I could write it. All right, or I could do the reverse order. I could say that two angles are congruent if and only if they have, or the angles have equal measure. You have one extra comma there. Okay, so again, the biconditional will work in either direction because it's true either way. It's a reversible statement. All right, next thing I want to do is work on pulling biconditionals apart. Okay, just making sure we understand that when we're given a biconditional, what information does that statement tell us? Okay, so problem 2 part A says, what are the two conditionals that form this biconditional? And the biconditional is array is an angle bisector if and only if it divides an angle into two congruent angles. Okay, so when I give you this if and only if statement, basically we get our two conditionals in both orders. So we could say one, the first conditional could be if array is an angle bisector, then it divides an angle into two congruent angles. Okay, so when I give you this biconditional, that's one of the statements I have. And then the other one would just be the converse of that. If a ray divides an angle into two congruent angles, then we could just say it is an angle bisector. Okay, so again, biconditional meaning two conditionals. And when I say this if and only if statement, these are the two conditional statements that it is telling me are happening at the same time. Okay, that this works in both orders. Okay, once again, I want you to hit pause on the video, give problem 2 part B a shot, and then again click play to check your answer. All right, so in part B, we want to figure out the two conditional statements that make up the biconditional. The sum of the measure of two angles is 90, if and only if they are complementary. Okay, well, the first conditional we can do is just an if-then statement in the order we see it. We'd say if the sum of the measures of two angles is 90, then they are complementary. Okay, then the other conditional statement we get is the same thing in the reverse order, the converse of the first one we wrote. We could say if two angles are complementary, then the sum of their measures is 90. Okay, once again, biconditional meaning two conditionals. These are the two conditional statements I get from this biconditional. All right, next thing we're going to look at is transferring from more normal everyday language to biconditional format. Now, this isn't necessarily something you're going to do just to have a conversation or just to write a paper, but it's good to be able to take a concept in normal everyday language and put it in biconditional format, because biconditionals are a very good way to think about definitions and how things classify. Okay, so we want to be able to do that. All right, so is this definition of straight angle reversible? If yes, write it as a true biconditional. Okay, so when we say reversible, what we mean is if we had conditionals, would it work in both directions? So our statement in everyday language is a straight angle is an angle that measures 180 degrees. I'm not going to write this out as a conditional, but we can think of it as a conditional format. If an angle is a straight angle, then it measures 180 degrees. And that is true. Now, if I go the other direction, I get something true as well. If an angle measures 180 degrees, then it is a straight angle. Okay, that's true. So I could say that this statement is reversible. Therefore, it makes sense to write as a biconditional. Okay, to do that, we need to split it up in kind of the two different subjects or the two parts it's talking about. We've got straight angle, and we have angle that measures 180. So what I can do for that biconditional is I can say that an angle is a straight angle if and only if the angle measures 180 degrees. Okay, or we could have done that backwards. We could have said an angle measures 180 degrees if and only if it's a straight angle. Okay, remember with the biconditional, it works in either direction. All right, that's part A. Once again, for part B, hit pause on the video, try to get the answer, try to get the biconditional on your own, and then press play to check your work. All right, for 3 part B, we have the statement an equilateral triangle is a triangle with 3 congruent sides. Kind of the two things we're talking about in this statement are equilateral triangles and triangles with 3 congruent sides. Okay, we want to check this statement for reversibility. Let's see if it works. If a triangle is equilateral, then it's a triangle with 3 congruent sides. I'd say yes, that's the definition of equilateral triangle. We can also go the other direction. If a triangle has 3 congruent sides, then it's equilateral. That makes sense as well. Therefore, we can write a biconditional. We can say a triangle is equilateral if and only if, okay, it has 3 congruent sides, or it's a triangle with 3 congruent sides. Okay, so there's my biconditional, and once again, we could have done that in reverse order. Could have said a triangle has 3 congruent sides if and only if it's an equilateral triangle. All right, last thing we're going to do then is not write more biconditionals, but use the idea of a biconditional to determine whether or not we're looking at a good definition. Okay, to be honest with you, you're probably not going to speak in a lot of biconditionals as you go through life. You're probably not going to write a lot of biconditionals in papers or anything like that. But you are going to have to think about definitions and classifications, and biconditional statements are a great way to do that. So here's what I mean. Problem 4, Part A says, is the following statement a good definition? Explain. Statement is a square is a figure with 4 right angles. Now, that is a true statement. Squares have 4 right angles. But I'd say this doesn't make a good definition because it's not reversible. Okay, so for example, if I think of this as conditionals, if a figure is a square, then it has 4 right angles. That's true. Okay, but if I go the other direction, if a figure has 4 right angles, then it's a square. That's not false. It's easy to make a counterexample of that claim. A rectangle also has 4 right angles, but it's not a square. Okay, so I'd say no, not a good definition because it's not reversible. It would not make sense to put this in biconditional format. Okay, part B has 4 more examples. Why don't you take a minute, pause the video, think through those. Are those good examples or not? And then hit play to check your answer and have me talk you through them. All right, so we have a few more statements we want to see if are good definitions. First one, dogs are animals with 4 paws. Now again, that is a true statement. Dogs have 4 paws, but I'd say it's not reversible because if an animal is a dog, then it has 4 paws is true. But if an animal has 4 paws, then it is a dog. That's false. Okay, tigers, for example, have 4 paws but are not dogs. So I'd say no, not a good definition because again, it's not reversible. Okay, 2, squares have 4 sides. This is kind of the same thing as the squares with right angles. I should change this example up. But yes, if it's a square, then it has 4 sides. It's true. But if it has 4 sides, then it's a square. Is not true. Okay, so once again, this is not reversible. Okay, third one's kind of a weird way to make a definition. I guess I've never seen a definition of Tuesday before. But Tuesday is the day before Wednesday. I'm going to say this is a good definition and is reversible. Because if it's Tuesday, then it's the day before Wednesday is true. And if it's the day before Wednesday, then it's Tuesday is also true. Okay, so we could make a biconditional out of this. It's Tuesday if and only if it's the day before Wednesday. So I'd say yes, as far as definitions for Tuesday goes, this is a good one. Okay, last one's a bad definition just for a different reason. An acute angle has a small measure. And the issue with this is I'm not sure what small means. That's not precise language. Okay, maybe small means less than 90, which would work. Okay, but if small means something else to you, I'd say it's not a good definition, okay, because it isn't specific about what small is. So this one I'd say no as well. All right, so there you go. There is our section on biconditionals and definitions. Okay, hopefully this biconditional idea helps you think about what makes a good definition and helps you determine whether definitions are good or not. Okay, start cranking through the homework, start working on that, and like usual, if you get stuck, we're here to help you out.